Okay, greetings from wherever you are joining me from today. My name is Everett Morris, and I'm from NetMerge, and I will be your instructor for this Azure AZ 900 Fundamental Exam Preparation tutorial. First, I want to start by giving you an understanding of who I am by talking about my experience. I am a software developer with over 20 years experience working in a Microsoft shop. Um, I've been manning different roles with increasing responsibilities, mainly as a software developer. I'm currently the CEO of NetMerge Limited, a small IT firm based in New York and Florida. Now, I took this exam earlier in January and I wanted to create this tutorial to kind of provide a comprehensive tutorial that someone else preparing for this examination could use as a guide and a preparation tool for passing this exam. Now, I'm going to be sharing my experience with you, what I encountered along the way, and I'll go through the different course content. But what I want you to understand is this is not a cram. This is an exam or a tutorial that I'm using the exact course outline as intended by Microsoft, and we'll be going through the entire document from top to bottom, going through all the different outlines and the different detail sections that is created by Microsoft. So I'll be following the entire course outline. I'm going to go through the course outline at some point, so you could actually get an understanding of the different features, the layout, and what to expect during the course. But if you follow the course outline, I promise you, you'll be able to ace the exam and do really well on it. So again, it's not a cram, it's a complete tutorial that goes through the entire content as laid out from the primary source by Microsoft. Now, I also want to talk about goals and missions real briefly. My goal is very simple for this particular course. It's just to provide you with sufficient knowledge and information that would exceed your expectation beyond the scope of the examination. I want to prepare you to do more than just pass this exam with a good score. I want to lay a foundation that you could build on your cloud journey, whether it be Azure or AWS or Google. I want to provide that foundation for you. Next, I want to talk about feedback. As with any product, feedbacks are very important. Your feedback is very, useful. I'm looking for your comments. I'm looking for your suggestions, your concern, or any feedback you might have. I want to see it in the comment section. And again, I want you to also subscribe. I want you to like, and I want you to comment. Those are the three things I'm asking for first and foremost if you find this video useful. Next, let's take a look at the support. Now, type of um this type of course itself, it takes a lot of work, a lot of effort to put together a real high quality course. Believe me, it's approximately about 80 to 100 hours worth of organizing, gathering, researching, and putting this course together. If you find the course useful and it assisted you, it was beneficial to you in any way, fashion, or form, and you want to support these kinds of training, please use the link below. There's a Cash App link. You could donate and you could actually support future courses or this course in particular. So if you want to support, I want you to subscribe, I want you to comment, I want your feedback. I also want you to like the video, and I also want you to donate if you see it fit and you're able to do so. All right, so let's move on and look at who the level of preparation that you would need for this exam. Now, if you're a developer with approximately 2 years or more experience, I would recommend approximately 8 hours worth of preparation. I'll explain what I meant by preparation in a few. Now, if you're an IT person with a little bit of experience, not 2 years or not a lot of experience, I would recommend approximately 12 hours worth of preparation. If you have absolutely no experience whatsoever with IT, you're a business manager, you're a decision maker, you're new to the cloud, you're new to computing, and you want to get a good understanding or a good solid foundation, I would recommend approximately 20 hours worth of preparation. And now I'm going to talk about what I meant by preparation. It's actually taking this video, taking notes, doing your research, using the Microsoft Learn Center, using the Q&As in Microsoft, and taking at least 4 or 5 practice exams. I paid approximately $11 for 13 exams, and they were very useful. They were extremely useful. Even after you finish the video, it will give you an understanding of how the exam is structured and how you should prepare yourself. And it will also refresh your knowledge and tells you if you need to go back and watch this video again or if you need to catch up on something. But from end to end, I will be going over the entire course, and I'm following the course outline, the syllabus as prescribed by Microsoft. Now, throughout this course, there's a big part on AI, artificial intelligence in Microsoft. I'm going to use my little bot service to help me with the introduction to get us started, and I want you to give me your feedback on the bot service as well. I also will be using it towards the end to summarize the course. It is going to be a quick bot summary that will help you to capitalize on what you probably missed throughout the video or throughout your research. So if you miss something, you could listen to it really quick, and if you're not familiar with the term and the context in which to use when I'm doing the summary, then you could say, okay, I need to go back and I need to refresh my memory on this, or I need to upgrade my knowledge on this. But I want you to do good on the test. I want you to get 900 or better scores, and I also want you to lay a foundation beyond just passing this test. Okay, so let's listen into my bot service that I want your feedback on, and then we'll move forward.
Introduction. The Azure AZ 900 Fundamental course is your first step inside Microsoft Azure Cloud Computing career. It is a 6-part, multi-section lesson crafted to get you familiar with the core Azure services and features in Azure. I will cover core cloud computing concepts and terminologies, and those features as they exist in Azure. The instruction is primarily theoretical, with few needed theories. My mission is to help you ace this exam and also be able to identify with Azure's core solution at the same time.
There's a bot service. I just want to introduce it, and I'm going to move right on now. Let's talk about the actual exam itself, the AZ exam. It is a 1-star fundamental entry-level exam. It is not something you would get excited about putting on a resume at the moment, but it's a very great starting point. It's a really great fundamental certification to have, and I implore you to start with a fundamental course before you enter into an associate or an elevated level course. I implore you to do that. So who should take this exam? Anyone who want to venture into cloud computing, more so Microsoft Azure, I would implore you to take this course. If you're a business leader, a decision maker, or a professional, or someone who want to get your feet wet in cloud computing, I also recommend this course as well. Now, why take this course? You should take this course if you want to pursue a career in cloud computing, or if you are a business manager or professional that is about to make a decision and you want to get a good, solid, fundamental understanding of what you are about to enter into, you should take this course. Now, when should you take this course? You should take this course before you venture into those arenas that I spoke about, and you should also take this course before you do the elevated courses, the associate level course, or even the expert level courses or the specialty courses in Azure. You would really appreciate it when you take the time to understand the fundamentals before you try to step into the solution midway. Now, where should you take the course? I implore you to take it right here with me. You should get all the information you need that could prepare you to help ace the exam. So you could take it right here, and I'll tell you further down in the video where you could sit the proctored exam with Pearson VUE as well. Now, what you can expect from this course? You could expect a solid foundation about Azure and cloud computing in general, and it's a good starting point for you to exceed your own expectations so you could walk into the other exam with confidence. Now, what I'm going to do next, I'm going to take a look at the roadmap as to where your journey could take you, and it will help you understand the who, why, when, where, and what I just spoke about. Now, let's look at the Azure certification roadmap in general. This is the roadmap. We're right here at the beginning of the journey with the Azure AZ 900 Fundamental. Now, if you want to take an associate level course, this is still a good prerequisite prerequisite for you. If you want to be an administrator, this is the course to take, the AZ 100. If you want to venture into data scientist, this is a course for you to take. If you want to be a developer, the AZ 203. If you want to be a data engineer, it's right here. If you want to be an AI engineer, it's right here. And you get an understanding of what you need. Now, to do the expert level course, one of these courses would be a prerequisite to doing an expert level course. Now, if you want to be a solutions architect expert, you'd have to sit two exams. You'd have to pass both exams to actually get this certification. And these are the two exams that you would have to take. If you want to be a DevOps engineer, you would have to take the AZ 400. That's the only exam you would have to take. Now, if you want to venture into a specialized field in Azure, these are the two specialized exams that you would have to take, the SAP workload and also the IoT developer AZ220. IoT, once you get into IoT, it's really, really cool. It covers billion of devices across the world. There's a massive support for it in Azure, and there are plenty of opportunity in IoT devices. If you don't know what an IoT device is, it practically any devices that you could monitor or control over the internet. When we get to the IoT section in section 4, or I believe section 5, I'll be doing an entire chapter on IoT, so you'll understand it a lot better. So let's move on. Now that you have a general understanding of what my background is and what the roadmap is for Azure and what the fundamental course is, we can move on now and take a look at the broad course outline. Now let's start with the course outline. It's a weighted average that Microsoft provided as a high-level guide. I'm going to be describing cloud computing first. It is approximately 20 to 25% of the coursework, and it's also weighted on your exam. This is the weighted measure on your exam. So I'm matching the weight that Microsoft has assigned to the course outline to the actual course content that I'm presenting as well. So that is chapter 1 of 6. In chapter 2, we'll describe core Azure services. Now we're going to get into the nitty-gritty of Azure. And the first chapter was about cloud computing in general. Now we're going to start talking about Azure in chapter 2. The third chapter, we're going to describe core solutions and management tools in Azure. There's going to be a two-section layout for that particular chapter. In chapter 3, I am going to be talking about general security and networking feature. Again, that is a two-part section, and as you can see, they're both 10 to 15%. Next, when you go to chapter 5, it's another chunk. It's a huge part, the second largest part. I'm going to be talking about identities, your password, your security in Azure. Azure is really big on security and governance and privacy and compliance, and they expend a lot of time covering this, and I'm going to be doing the same as well in chapter 5. Then we get to the final chapter. It's the shortest chapter. It's a really short chapter. It's 10 to 15% of your grade. I'll spend 10 to 15% of my time on that particular chapter. We're going to be talking about Azure cost management, how to manage and contain costs, and we're going to talk about service level agreement, which is a mutual agreement between you and Microsoft. So there you go. You have an high-level solution of what we're going to be covering. What I'm going to do, I'm going to show you where on the Microsoft site you could find the latest course outline so we can have an understanding. So let's go right over. First, you want to go to your favorite web browser and you want to type in Azure AZ 900. Once you start typing, you will see the course AZ 900 comes up. You just want to click on it and you want to navigate down properly and make sure you're looking at the Microsoft site and you're going to the Microsoft AZ Fundamental 900 Learn website. You want to click on it and boom, there it is. That's the website. You want to scroll down, and while I'm scrolling, I want to stop. This is the actual cost of the exam. It's very inexpensive. It's among the cheapest of all the exam because it's a fundamental entry level exam. It is $100 for the United States if you're in the United States and for most other places. Let's look at the Ukraine. They're in the news. It's only $55 in the UK. So Ukraine. I'm sorry. So I'm assuming it's on based on your ability to pay. Now you could take the exam at a proctored site. Pearson VUE is the site that Microsoft paired with to do the exam. You could take it at home, but I recommend you take it at a Pearson VUE site. You'll have all the resources you need to take it, and you won't have any security or any concern issues. You would take it at the proctored site where it's monitored, and you won't have to worry about it. What we're looking at here at the skill sets measured is exactly what I just went over with you, which is a high level overview of the course. What I'm doing right here, I'm here for this particular reason. This is an updated version of the course, and you could look, it was updated in January 2020. January 25, 2022, so it's very recent. I took the exam in and around the same time, and I start preparation for the course in and around the same time. It is now March 1st, and I'm doing the recording for the exam. Now, you could browse through at your leisure, but what I want you to do is to download a physical copy. I show you where to go and follow along with your physical copy so you could get an understanding of what you need to know for the exam. If you follow my video tutorial and you follow the course outline, you should do very well on this exam. It's not very easy. If it's your first exam you're going to be doing with Microsoft, you want to follow the procedures. Now, the passing grade is 700. You should strive to do 900 or better on this exam. And if you follow my video tutorial, you should be able to do that with some research and some other forms of preparation, including sitting the exam. My website is not ready as yet, so I don't have the exam prep on my website, but when we do in the middle of, say, June or July, you would be able to go there and get preparation tests and exam that you could do practice tests for the exam. So let's get back over to the video and let's start doing our training with the Azure AZ Fundamental Exam. All right, so I'm going to switch back over. Okay, welcome back. Again, my name is Everett Morris from NetMerge, and I will be your instructor for this Azure AZ 900 Fundamental tutorial. Now, let's get started with actually understanding what we're talking about with Azure. So, what is Azure? Azure is a public cloud computing platform owned by Microsoft that allows you to emulate and deliver computing services over the internet remotely. So that's just a basic overview of what Azure is. We'll be talking about Azure so much. I want you to understand the course itself says Azure AZ 900. So right out the gate, I want you to understand what Azure is. Now, computing services include but not limited to servers, storages, virtual machine. When I said servers, virtual machine, database, networking, and software services all combined. So I want you to understand these terminologies as we get into Azure. There are three layers to services provided by a cloud service provider, not necessarily Azure, with AWS or anyone else. And the three levels are IaaS, which stands for Infrastructure as a Service, PaaS, which stands for Platform as a Service, and SaaS, which stands for Software as a Service. Get familiar with the terms. I'll be talking about them in a lot more detail, so by the time we get to through halfway through the course, you'll be so comfortable and you'll understand them so clearly you won't have to worry about them. But I just want you to understand upfront that those are the three layers of services that will be provided by a cloud service provider, CSP for short. Now, as it relates to market share, Microsoft Azure has approximately 21% of the market share as of 2022. The market leader is AWS, Amazon Web Services. So this course is geared towards Azure, and we're going to be focusing on Azure. AWS is a separate course that I'll be doing for AWS directly. Now let's move on and start talking about the course itself. For this particular course, it's going to have three sections for this chapter. What I'll be talking about first, I'll be talking about the benefits and configuration of using cloud computing service. And this will be cloud computing services in general. So I'll be starting off talking about high availability, scalability, elasticity, agility, disaster recovery. Then I'll move on to talk about the difference between capital expenditure and operational expenditure, CapEx, OpEx for short, and then I'll describe the consumption based model as the first module. When I get to the second module, then I'll give you a session overview of what that entails. So let's start out by starting our first part of the course and going directly into some terminologies. Now, I want you to understand these terminologies because I'll be using them quite frequently as well throughout the course. A resource. What is a resource? It's anything that you can create, use, or manage in Azure. So a virtual machine is a perfect example of a resource, a web application, a database such as a SQL or PostgreSQL or Cosmos DB is an example of a resource. A storage device such as a blob storage or containerized storage is an example. So any resource that I can create within Azure or you could create within Azure is considered a resource. So that's a general understanding. A resource group is really a container or folder or holding place that you would use to control all your resources need. So for a particular project or solution, you could group those resources that you just created in a resource group so you could organize and manage them more cleanly. Next, I want to talk about a resource provider. If you're coming from a software development background and you are familiar with namespaces in Azure, for example, it is like a service provider. Your resource provider, it allows you to execute a task. It is the conduit to creating a resource. So, for example, the Microsoft Compute would be the resource that we would use to create a virtual machine up top or a server. So, the Microsoft storage is what we would use to create a storage device in Azure. So you get an understanding as to what a resource is. Next, I want you to understand service. I deliberately talk about resources provided first because to me it underscores what a service is. So a service is what you would use to create all the resources that we talk about. It's a tool that you would use to create a resource or a compute service in Azure. So you get a general understanding of what those different terminologies are. So let's move on now to actually look at the first part of the course, which is general high availability. So what is high availability? High availability in cloud computing is the ability to keep your service up and running optimally with near nil downtime. So when you hear the term high availability, I just want you to simply think about uptime, the percentage of uptime. If you're up 100% of the time or 99.999% of the time, that is what high availability is about. Now, scalability is the next critical piece of Azure. Azure is all about scaling massively and the ability to grow and use resources abundantly, rapidly, in an infinite manner. So you want to be able to think about scalability when you talk about Azure. So scalability is your ability to grow seamlessly on demand when the traffic demands more memory, more computing power, or greater demand. There are two types of scaling. There are vertical scaling where you scale up and horizontal scaling where you scale in and you scale out. I want you to understand the difference between the two. They're night and day. Scaling up is really an upgrade on an existing resource to meet demand. So if you have, say, for example, a computer and you upgrade that computer, that is vertical scaling. It is scaling up. You increase the memory, you increase the CPU, you increase the hard drive storage from 100 gigabyte to 200 gigabyte. Now you have data on that gigabyte, you have 150 gigabyte of data. You scale up and you use it. You cannot scale back down. If you change the size of the hard drive, you destroy the data. You destroy the integrity of the data. Your files are corrupted. Your system will not work. So vertical scaling is upgrading an existing system and it goes in one direction. I want you to understand that. Now let's move over to elasticity or elastic scaling. This is horizontal scaling. When you see elastic scaling, think about horizontal scaling. It is the ability to grow and shrink seamlessly horizontally, or you could scale in and out on demand. It is adding more of the same resource configuration. So in the instance where you have a computer, you would have to create another computer. You're not doing an upgrade, you're expanding, you're increasing, you're adding more of the same. If you don't need those resources anymore, you get rid of them and you scale back. So think of elastic scaling as cloud scaling, and think of scaling up as on premises or traditional legacy type of scaling. So, elastic scaling is what we'll be focusing on inside of cloud computing. Now, let's talk about a type of elastic scaling in cloud computing. And in Azure, we have what is called a VM set. Now, in Azure, it allows you to scale in and out elastically by adding new virtual machines or servers of the same configuration to meet a demand and deleting them when they are no longer needed. So you could allocate and deallocate them on demand. You could add and delete them on demand. So you could stretch and you could shrink on demand. You could go in and you could go out on demand. That is what a skill set is. We'll talk about it in more details, but to drive the point home, I want you to think of this scenario and then you should be able to understand. Let's say, for example, the Olympics, Winter Olympics is going on in China, and you need the Olympics committee need 1,000 computer for their employees to actually monitor and do their administrative work at the Olympics. If you were to do that in the real world, you'd have to order 1,000 computer, you'd have to take them out the box, you'd have to configure them, you'd have to load your application on them, and you'd have to assign username and password to each of them before you give it to the users. I'm sorry. Now, with the cloud, if you're doing cloud computing, you could just create these machines and you could just scale them in a VM set, and one person could do that versus the amount of time and resource you would need to do it in a traditional manner. So that's what a VM set is like. Keep the concept of 1,000 computer needed for the Olympics in your mind, and I'll keep coming back to that concept to drive the point home. Now, there's a second type of elastic scaling in Azure, and it's called a SQL Stretch Database. It's not really a common feature, but it is a feature nonetheless. And what it does is, if you're on premises, on site using your database and you maxed out that database because 1,000 people at the Olympic and the entire Olympic world want to use your server and you cannot manage, you could scale into Azure, create an hybrid service, and you could use your on premises and Azure database to manage that service. And once the Olympic is over, you don't have that demand anymore. You could come back out of Azure or your cloud service provider and go back on premises and use your own database. So a stretch database is really an hybrid solution. Now, what I want you to take away from what I just mentioned about scalability is that vertical scaling is upgrading on existing resource, like that one old server you have on site, that legacy server, and horizontal scaling is done on new resources, and it can move in and out, and it's the ability to scale elastically inside of the cloud. All right, so you get a good understanding of what scalability is. Now let's look at some simpler features in cloud computing that we'll talk about. Now, when we talk about scaling just now, that is agility. It's the ability to react, respond quickly to a request. In cloud computing, you're able to do that. You have great agility. You're very agile. You're enabled, agility enables users to be able to allocate and deallocate resources very quickly, and that is a huge benefit of the cloud. So you understand what scaling is and how it plays into the agility model. Now, disaster recovery is a part of high availability, which is the first thing we spoke about when we start the course. Now, disaster recovery is also high durability, and it is good fault tolerance. Fault tolerance is your ability to withstand a fault. It's your ability for one of three computers to go down and you have two more computers remaining to withstand that fault. So it's your ability to withstand a failure, a fault. Now, the ability to recover from the disaster without any data loss, any data integrity issues, or downtime is one of the hallmark of high availability. So I want you to understand that. So in the instance where you upgrade your virtual computer and you upgrade the hard drive, if that single hard drive should fail, you have no disaster recovery, you have no high availability, and you have no fault tolerance. So I want you to understand the difference between the two. Let's move on to something else now. Now we're building on the structure. Now cloud, it is global. Now global, you can operate from anywhere in the world by selecting a region close to you. Currently, Microsoft Azure has approximately 60 regions in 140 different countries worldwide. So they're global. They have a global footprint in the cloud market space, and they're consistently growing. So Microsoft wants you to understand that. Security, cloud provider take great care in providing a high level of both physical and technical security. Physical security would be your surveillance, your biometrics that you would use to get into the building, your palm scan, your eye scan, those type of things. That's your physical security. The actual security guard. Your technical security is your firewall, your employees, your security guards. Now, your security guards would be part of physical security. So your firewall, your if you're using Active Directory, whatever software you're using to manage your employees' identity, that is a part of your technical security. So you get that with the cloud, and you get a lot of expertise with it as well. Now, current, the cloud is current. Updates and upgrades are done seamlessly with zero downtime. The provider takes great care in those services in a cloud service environment. It is done transparently. You don't have to worry about it, and they do this using update domain, and it's considered a planned incident. When we talk about update and fault domain further down in section 2, you'll get a better understanding of what update domain is, and you'll understand better what it meant when we said that the cloud is current. For now, you just want to understand that updates and upgrades are done and they're transparent to you. So what I'm gonna do now, I'm at a different part in the course outline where I'm going to be looking at expenses, and I want you to understand the difference. Again, what they're doing in this first chapter is drawing distinction between legacy on-premises data center and a data center that would be in the cloud if you're using cloud computer. So when we talk about capital and operational expenditure, that is exactly what we are talking about. Capital expenditure has to do with your physical asset or the physical cost of managing, honing, managing, running a data center. Operational expenses covers doing it in the cloud. So we'll spend more time on the operation side or the cloud side of this. Now, the entire process of doing the assessment, when you're comparing and doing your compare and contrast between costs, that is referred to as economies of scale. It's part of the larger total cost of ownership assessment that we'll talk about in the final chapter when we talk about cost management. For now, you need to understand that capital expenditure or physical expenditure and operational expenditures are tangible, intangible expenditures that you cannot really touch or feel. Now let's take a deeper look at it. So capital expenditure, short CapEx, has to do with your physical upfront costs of hosting an on-premises data center. This is usually a huge, unpredictable physical investment that you would have to make upfront before you could own a data center or operate a data center. You usually purchase a lot more resource than you need because you're planning to grow into those resources. So there's a lot of waste in operating a capital expenditure data center. Now, the operational expense has to do with your public cloud as an alternate solution. Now, to understand a public cloud, we have to talk about cost-based model, which is one of the most attractive incentives in cloud adaptation. It is said that when you move in the cloud, you should see a 75% cost reduction between your OpEx expenses versus your CapEx expenses. We are using a model called pay as you go or PayG, which is a terminology I'll be using from here on. It is a very fluid pricing structure, and it gives you accurate and concise upfront costs as to what your resources would cost you if you should adapt or move into the cloud. There's an entire course on the adaptation process and how to calculate the cost, and we'll talk about that when we get to that course. But you want to understand that in general, the cloud is cheaper because you're doing consumption based modeling. You're paying as you go, you're paying for what you want. And if you use the example that I asked you to retain about the 1,000 computer, if you leased or rent those 1,000 computer from a cloud service provider, once the Olympic is over, you don't have to worry about getting rid of those computer, which is what the Olympics has been doing for years. They have to find a third party vendor to auction off those computers for them so they could recoup some costs. They no longer have to do that with the cloud-based model and what we are actually venturing into with cloud-based computing. Now let's look at the core benefits of CapEx versus the OpEx model. So OpEx as an incentive over the CapEx, it's cheaper. Now the solution that makes Azure it makes Azure robust, it makes it effective, and it makes it efficient as an infrastructure for a cloud service provider. You could rationalize that. I explained to you how much time it would take to order 1,000 computer. It has to be shipped, it has to be packaged, it has to come back to you. You would have to break it down. You would have to do your installation. You'd have to assign usernames and password. It will take you approximately a month to do that with a sizable IT team. In the cloud, one person could do that for you within a few hours, if not a couple minutes. Okay. Now, you also get on-demand scaling solution and option to support elasticity. That is exactly what the cloud is about. You can grow rapidly. You could scale massively in the cloud. You could create 1,000 computer really fast in a rapid fashion. That's a benefit. You get dynamic scheduling of software releases from month to days. Instead of waiting for a particular window or an holiday to do updates and upgrades, you could do it seamlessly in the cloud. So you get that dynamic fluid feature. Now you could scale massively. You have the ability for your compute, your mobile, your storage, and web services to grow on demand as you need it. And you pay for what you use, so you're not losing any money buying an expensive server that it's going to take you 2 years to grow into it. You grow on demand with the cloud. Now you get ground up support you can trust and rely on with high availability backing it up in the background. So a cloud service provider would have multiple data center. You would just have one data center or a backup data center. With a cloud service provider, you're getting a lot of different availability zones or data centers that you could use in Azure or with a cloud service provider. So these are some of the core benefits. They're really good benefits that you get when you use the cloud. Now, what I'm going to be doing, I'm going to be talking about a different session now, and we're going to be venturing in a different part of the cloud model, and I just want to give you a session overview of what we'll be covering in this section. So what I'll be doing, I'm going to be talking about shared responsibilities. I'm going to expand on the 3 services that I asked you to remember, which is infrastructure as a service, IaaS, platform as a service, PaaS. We'll be talking about serverless computing briefly. Then I'm going to go on and talk about service types and the different use cases for cloud-based services. So let's get started with this session. It's a second session. I think we're doing pretty well. We're moving at a decent pace, and you should be understanding what I'm doing at this point. So shared responsibilities is a different responsibility or the mutual responsibility that you would have as a tenant or as a customer when you move over into a cloud service space using a cloud service provider. That is what that is. That is what I'm going to be explaining to you. Now let's get started. Shared responsibility model, also known as the division of responsibilities model, has to do with how responsibilities are divided or shared among cloud service providers, CSP for short, and customers. And customers are also referred to as tenants in a cloud space. Now, the workload responsibilities vary depending on where the workload is hosted in the cloud. I'm going to use a pyramid called the cloud pyramid model to give you an understanding next. But for now, you want to understand software as a service, platform as a service, infrastructure as a service, and on-premises data center. On-premises data center, I'm not going to elaborate on because that's out of the scope of the cloud at the moment, but I'll bring it in at the opportune time and when I'm doing comparisons. So let's focus on the different service type and how your responsibilities are divided based on the service type that you are using. Now, here's a pyramid to help drive the point home. At the bottom of the pyramid is your infrastructure as a service. This is where the cloud service provider would have their physical networks and their servers that they want to lease to you and their computers that they want to share with you. The middle tier is for developers. That's a different type of end user. And the top tier is for end users. So if you're using Microsoft 365 and you're writing macros in Excel, this is your area right here. If you're using Gmail or Google or Microsoft account, Outlook, software as a service would be your tier on the pyramid. So let's introduce the different things that could take place at these levels so you get a better understanding. So at the infrastructure as a service, the core compute, your virtual machine, your storage type that you would need to save your information, your networking resources to create your network is offered at this level at a basis, pay as you go, consumption based model. Now, in the second tier, it's for software developer. It's a middle tier framework for software developer with third party resources that you can use to build and test application. So this is where your databases would reside. All your databases, your PostgreDB, your SQLDB, your Cosmos DB, these is where you would have your database. So if you're coming from a Windows background like myself, your Visual Studio would be here. You would have your Visual Studio Code. If you're coming from a Java background, your Eclipse application, this is where you would install and use those applications. Now, if you go to the software as a service level, this is the end user or the lightest end user model. This is a solution where you log in, you pay for a subscription, and you go through your web browser, for example. I want you to ignore this P in the platform as a service. It should be an S. I don't want to confuse you. I'm sorry about that. Yeah, but your Google Gmail, your Office 365, your Excel file, you're going to create an Excel file called AZ900, and you're going to be putting your progress in it, and I'm going to be using that as an example throughout. So think of that imaginary Excel file that you're going to be creating in Microsoft Excel using a spreadsheet with a bit of macros to actually create your first coursework. And then TurboTax, those type of services are what you would get at the software as a service model. Okay, so let's move on to the platform as a service pros and cons. So you get agility at the PaaS level, and we understand what the agility is. And again, remember, it's a server computing level. Next, we want to talk about platform as a service. You can focus more on the core framework skills that drive results, such as software engineering, and you don't have to worry about the infrastructure efforts or the works necessary to configure the service. That's why it is referred to as a serverless computing model as well, or the serverless computing aspect of the service type. Next, we want to look at availability. It is even higher with the cloud service provider managing both the infrastructure and the platform backend layers for you. So you get that as a benefit. It also reduces coding time with plenty of pre-coded workflow solutions that are available to you in the marketplace. I'll explain what the marketplace is later. I don't want to confuse you at this time, but you're able to focus more on coding at this point, and you could bring in pre-coded code solutions that are already pre-factored for you to a certain degree. You also get exceptional off-the-shelf deployment capabilities, support that you could use to do remote with your remote team members to do deployment and testing. You get that benefit at the platform level. You get the flexibility to also manage an entire application life cycle from the moment you came up with the idea until the point where you retire or sunset that application. Now, this is a single disadvantage, and like I mentioned, each section have a single no noteworthy drawback. The biggest disadvantage is that you get less control over your infrastructure, and that limitation can impact application in the end result in production. So the testing you do, you have full control over the solution when you're testing. When you deploy it into the cloud, there's some features and capabilities that you could lose or that you didn't intended, and the production environment is a bit different from your actual testing environment. So that is one of the drawbacks. Now let's look at the benefits you get at the infrastructure level. It is the most dynamic category of the cloud service with near absolute control for the consumer or the tenant. Your domain, it's your domain. It's a domain with notable benefits to you. Now, you get agility, the same kind of agility you get with any of the other services. You also get shared responsibility that allow you to focus only on the service you provision. You also get back-end risk. It's completely offloaded to the cloud service provider. So Microsoft has to worry about the data center upkeep, the maintenance, the staffing. You don't have to worry about that. You just pay for what you use when you use it. You also get endless talent base from the cloud service provider that could be used to complement your actual in-house staff. So you get high availability, rigid security, and a good top-down security or bottom-up security using the cloud service provider. Now to the disadvantage, you lose that deeply granular control over the infrastructure, especially where security is concerned, and selecting your preferred gear and appliances, you're not able to do that at this level. So if you're coming from a Cisco background and you have deep knowledge in Cisco and you want to use that knowledge and you want to use your own Cisco hardware, you don't have that liberty in the cloud. You have to use whatever hardware Microsoft is using in their infrastructure. So those are the benefits, the pros and cons that you would get using the cloud, um, the responsibilities in the cloud. Now, before we look at the service types and use case, which is something Microsoft want us to understand before, and it is going to be on the exam, you have to be able to identify these use cases and determine when you would use what service type and what level you would use it at. Before we do that, I want you to understand the service categories one more time. It is that important. You should understand what the software as a service is about, the platform as a service, the infrastructure as a service, and on-prem. When we talk about on-prem, we're talking about your own data center. Now let's take a look at the consumption-based model, which is the pay-as-you-go. I'll come back to the actual use case scenario once I'm finished with this. Now the consumption-based model or pay-as-you-go, it affords you a more granular cost for micro-billing and operational expenditure. So this is a big thing for the serverless computing and the consumption-based model. That's one of the benefits you're going to get from the shared responsibilities. You also get high availability with the cloud service provider managing the entire backend. They have a lot more data center than you would have in 2 or 3 data centers. They have a lot of data centers combined that they pull together with high performance fiber optic cable, so you get better support and better availability. It is also global and it is also current. I went over those already. I'm not going to go over them again because you should understand what they are. Now, one thing I want you to understand, when you save something in Azure, your Excel file that you created detailing your course progress, when you save that file, you're going to get 3 copies of that file in one availability zone or one data center within the structure. So what you're getting is what they refer to as LRS, which is localized storage, and I will talk about that as well. You also get access to a larger pool of expert and technical resources as well. You get almost limitless scaling and geo redundancy. We'll talk about geo redundancy again when we talk about LRS storage. I don't want to confuse you with that at the moment. Now, when we talk about serverless computing, you must learn to associate it with the platform as a service infrastructure level. That's a PaaS service. So you're able to build application faster because you're eliminating the need to configure and focusing on infrastructure need. If you're a software developer, you could just come in and focus on software development and you won't have to worry about anything else. Now, the most common form of serverless computing are functions and logic apps. I will be going over these in more details as we go along, but I want you to understand that they're designed simply to solve complex orchestration challenges. If you're coming from a Microsoft background like myself and you write codes in .NET, you understand what a script is. If you're coming from the Java background, you should understand what a script is. So there are event-driven code, snippets of code that you could do, and you could do them in your own scripting language if you're using Node.js, Java, machine learning, workflows, Python. You could even use PowerShell or CLI. I also want you to understand there's a lot of support in the marketplace, which I'll talk about again for you downstream. What the marketplace is for now is just a third party site that you could go to purchase plugins and connectors that you could use to complement your development in a cloud service environment such as Azure. So we identify those. You understand what page is. You understand the different model. Let's take a look at what a use case scenario would be like, which is something they want us to do with this course. So you need a subscription first to do anything in Azure. I want you to understand that. You need a prepaid subscription, a free subscription. You'll get a free subscription when you sign up with Azure the first time for approximately $200. You could use it to actually play around with Azure and try it out for 30 days. I want you to know that. Now, you're deploying an application in a situation where the company needs control over the operating system and the security patch for your virtual machine that you created. You need to be able to identify if that's a platform as a service, software as a service, or infrastructure as a service. Now, where you would not be doing this at the software as a service level, where you want to log into your Gmail and check email. You don't have that liberty to do that at that level. Nor do a developer have that at the serverless level. You're not working with the servers. You're not able to configure the servers. So this is definitely an infrastructure as a service level you're looking at right there for that requirement. So that's a use case where you would have to be able to rationalize the need for a use of one of those services. Now, if you need a database or have some software to develop, that is a giveaway. I spoke about all databases operating at the platform as a service level, and I also use the word develop. So once you see the word software to develop, you know that takes place at the platform as a service level. Now, similarly, your email, if I should talk about something about your email, you want to be able to identify that with your software as a service level as well. And then this is the absolute question. Suppose you need absolute control over all your resources. Then you need to keep it on premises. You're talking about on premises resource right there. So you should have a good understanding. You should get a full understanding of how the process actually work for cloud computing. Now, I think we're at a point where we're going to be looking at the third component in this first chapter, and we're going to be talking more about cloud computing. So let me just give you an overview of what we're going to be talking about in this cloud computing section. So we are going to be talking about computing, cloud computing in general. We're going to be talking about the public cloud, the private cloud, hybrid cloud, and we'll be comparing and contrasting the different type of clouds. So stay tuned. This is what we're going to be talking about at this particular level. So I partially described cloud computing which is when I described Azure earlier. So, cloud computing is a virtual delivery of computing services from a network over the internet um, remotely. So, cloud computing services include servers, storage, databases, network software, analytics, IoT, and intelligence. Those are some examples of cloud computing. And what we're looking at here is just a graphical illustration of what cloud computing would entail in general. Now, let's take a look at some of the more detailed definition. Cloud computing, it should be fast, it should be innovative, it should be flexible as economies of scale build in it. You should see benefits up front, and it should be easily accessible. Now, cloud computing benefits should be cost, it should be low latency, it should be fast, it should be productive, it should be reliable, it should be durable, it should have high availability built into it, you should get performance, you should have good security, and accessibility should be global. We talk about those things. So now let's examine the evolution of cloud computing. So to better understand the future where we're stepping into with a cloud computing, let us step back and glance at the past and the present. Now, first we had dedicated servers, and then we had private servers, then we had shared hosting, and now we have cloud hosting for public and private clouds. And I'm gonna step into all of those one after the other. Now, dedicated servers was one physical machine dedicated to a single business running a single web application. So it's a one-on-one setup. This was very expensive and it comes with high maintenance, but it also carries a higher level of security with the right expertise in house. You could configure your own security. Then we have virtual private server, one physical machine that is dedicated to a single business, but the server is virtualized. If you're coming from a Windows background and you understand hypervisors, you're able to create multiple virtual machines on a single server. So you're able to run different web applications, so you're able to run more than one web application on a single machine using virtual machines or VMs. The next step in the evolution process was shared hosting, one physical machine shared by many businesses on a rental basis. This was very cheap and also very limited. Limited in the sense that there were no resource equity among tenants. There was no parity. So if you have a customer like the Olympics, they have a period or a busy time, they would consume all the resources on that network while the Olympics is going on and they have a need for 1,000 computer. They'll use up all the resources, and another sports group would have to wait until they're completed before the resources are available. So there were no parity, so that was the biggest limitation for shared hosting. Now we get to the cloud model, the private and public model that we are accustomed to today. Now, this umbrella system is abstracted into a plethora of cloud hosting services and tools that we have at our disposal. Cloud hosting is very fluid. It can be scaled very rapidly and massively. We understand that it's elastic, it's extremely secure, it's ironclad protection, it's very cost effective, and it's easy to configure. We get that. With the private cloud, which is your on prem data center, the functions are similar to the public cloud, but you're the only tenant. There's no one sharing resources with you, and there's still a need for that. And Microsoft understands, and they made provision for on-premises support in a lot of situation, as you'll see when we go through the course. Now, the public cloud is where Azure fits into the cloud puzzle, and where we will start to talk about Azure. Public cloud is also referred to as native cloud outside of Azure. So Azure uses different names and terminology throughout their operation to refer to different things, but native cloud is really the public cloud. Now, one of the powerful resources you have that you can use to maintain both your own private cloud and connect to the public cloud is a resource known as OpenStack. With OpenStack, you would have a public subnet with having your private subnet running inside with all the tools needed to deliver core cloud services at your fingertips. So if you want to host your own cloud or your private cloud, you would need OpenStack. It is a open source solution that is able to do all the hypervising for you, all the requirements that you would need for operating a cloud on your own. You could be able to do that, whether it's your own private cloud or if you want to venture into the public cloud, you could use OpenStack to maintain your own data center. So we'll talk more about OpenStack, but you want to understand what it is used for. Now, hybrid cloud, we're going to be talking about the cloud concept. So let's look at hybrid cloud. We talk about the private cloud, and I spoke about the public cloud. So a hybrid cloud is really a combination of a private cloud and a public cloud technology. So you're merging your on-prem with Azure or your cloud service provider to form a new type of solution. You're using two solutions, you're combining two solutions to form one. Hybrid clouds are recommended and they're connected with a service referred to as Express Route. There's an entire section dedicated to Express Route, but for now you just need to understand that Express Route is what you would need if you're trying to connect an hybrid cloud, a private data center to the public cloud service provider. It's a really fast, low latency connection between two sites, and it's very common in the marketplace. So Express Route, you need to know what it is and what it's used for. You're looking for the super fast connectivity that doesn't go over the standard internet, you need Express Route. This is an example of the Express Route. It's just a little diagram. This is the Express Route symbol. This is your Azure cloud. This is your on-prem data center right here. And you're using a collation provider, which is a high-speed provider, much faster node-to-node connection than you would get at the internet level layer 7. And that is what you would use Express Route for to get those connectivity going. Okay. So we look at the cloud concept and we look at the model. There's also a cross cloud model. This might not be on your exam, but it is still something that worth mentioning so you have an understanding. And again, the goal is not for you to pass the exam, but to understand cloud computing to a T. Now, it is a combination of more than one cloud service provider. So it would be as if you're connecting for whatever particular reason a large organization would have. It's a combination between, say, for example, Microsoft and AWS Azure Web Services. The tool that Azure provide to help facilitate that is Azure Arc. It provides a bridge for cross-cloud services. There's also another service called xCloud, and xCloud is also a very popular provision with extremely large organization having a unique need for ultra high availability. So you would do this when we talk about region peering in Azure. You'd understand that this is like region peering, but on a much larger scale, on a grander scale, and it's also very expensive, as you could imagine. Now, this is the actual symbol for the cross cloud peering that you would have access to in Azure. All right, so at this point, we're getting to the end of the first chapter, chapter 1. And what I'm going to be doing, I'm going to be comparing the different cloud models to explain to you what the difference are as it relates to cost, security, configuration, and knowledge. So let's do a vertical comparison on cost. With the public cloud, your cost, it would be more cost effective at the public level if you use a public cloud. Private cloud would be the most expensive. Hybrid cloud, depending on what direction you're leaning in, it could cost less or it could cost more. With security, same thing with the public cloud. It is done for you by default. Yes, it could be sufficient, but it should be sufficient enough coming from the cloud service provider. For the private cloud, there's no guarantee about security, but you can meet all your requirements if you have the right skill set in-house. For the hybrid cloud, security, again, it depends on what direction you're leaning, but you would need skill set for both in order to maintain both your on-prem and cloud provision. Now, for configuration, It's limited configuration that you have to do with the public cloud. You have to do all the configuration with the private cloud. Again, with the hybrid cloud, you would need knowledge in both the private and public cloud. Now, as it relates to knowledge, in the public cloud, you only need the functional knowledge for the different types you're using. If you're using the Excel file, you just need to know macros and Excel, features to be able to function. If you're a software developer, you just need to know how to code within your respective field. If you're using a private cloud, you would have to know everything. There's no help, no one to help you or guide you. Um, for the hybrid cloud, the knowledge again, you would have to have knowledge for both public and private cloud. So you would need to have a deep cadre of knowledge for both. Now, this should take us to the end of the chapter 1, and we should be venturing to chapter 2. Let's take a look at that and see where we are. Yes, this is chapter 2. So we're at the end of chapter 1. We concluded chapter 1. And again, my name is Everett Morris from NetMerge. This is your Azure AZ 900 fundamental training. I'll see you in chapter 2 or part 2.